This question says, how many molecules of carbon dioxide is 16.4 grams of carbon dioxide? So carbon dioxide, as you may be familiar with, is CO2. And we're given grams of CO2, and we want to know how many molecules of CO2 that we have. Well, there's no direct conversion between grams and molecules. So we need to convert from grams to moles to molecules. And as in many of these questions, it's a good idea to do them kind of in order and look at the videos for the previous questions if you're not sure how to do some of these things, as to not be making these super long. Some details will be left out if they've been covered in previous questions. So in this case, we want to convert from grams of CO2 to moles of CO2, and then finally to atoms of, that's not atoms, molecules of CO2. Okay, atoms would be if it was just carbon or just oxygen, but because it's carbon and oxygen, two or more atoms makes a molecule, so it should be molecules of CO2. So grams to moles has already been covered. So now the new thing is moles to molecules. Well, we need to know that 1 mole of CO2 or anything else is equal to 6.022 times 10 to the 23rd, in this case, molecules of CO2. So a mole is like a dozen. It's a number of convenience. You can have a dozen bagels or a dozen donuts or a dozen beers, okay? Just like a mole. You can have a mole of carbon dioxide or a mole of oxygen or a mole of iron. Okay, but when you do, you have 6.022 times 23 of the things. So that's what a mole is, just like a dozen is, you have 12. Okay, so it's the same idea. So we need this equality in order to make this conversion. So to go from grams of CO2 to moles of CO2, we're going to use the molar mass. You can do this two ways. You could either Google molar mass of CO2, or you could just look here, and you have a carbon, 12.01, plus 2 times 16.00, which gives you 44.01. It's a small molecule, so it's not that hard to calculate it. So starting with 16.4 grams of CO2. Now we need to find the number of moles. Well, because we have grams, we want to put the grams, the molar mass, on the bottom. So we put the 44.01 grams of CO2, which again is carbon plus 2 oxygens from the periodic table, and the 1 mole of CO2 on the top. Now we want to convert from moles of CO2 to molecules of CO2. In order to do that, we want to use Avogadro's number. And as usual, we want to cancel out this unit and end up with the unit we want, because in this case it asks us how many molecules. So we want to put the 1 mole of CO2 from this equality on the bottom, and the 6.022 times 10 to the 23 molecules of CO2 on the top. Now, when you're doing this, you need to be careful with your calculator. In this case, we're multiplying by Avogadro's number, so it's not that bad. But if you're dividing by Avogadro's number, the order of operations are a problem. So if you have a Texas Instruments calculator, you want to use the EE key. Okay? And for a modern Casio calculator, it's usually the 10 to the X key. Although for an older Casio calculator, it could be actually the EXP key. So you want to use these keys. So if you wanted to type in Avogadro's number on a Texas Instruments calculator, you type in 6.0222. You would push the EE button, which really annoyingly only puts one E on your screen, and then you would put in 23. So the E that you see on your screen by pushing the EE button is the exponent. So it's just this part. You don't type in the times 10 part at all. So it's 6.022 EE, which gives you the 1E, 23. If you're doing it in the Casio calculator, you hit 6.022, you hit the 10 to the X button, and then it brings it up to here, and you put 23. And I think on some of them it'll actually put times 10 to the, and then the 23 will be above. Okay, but that's basically how it works. You don't type in the times 10 to the X, you just push the button, and then it shows up on your screen, and then you put the 23 in. So that's basically how it works. So multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. We have 3 sig figs here, so we want to round our answer to 3 significant figures. And when we do all this math, we find that there are 2.24 times 10 to the 23rd molecules of CO2. Okay, and that gives us our answer.